in that case. It's a similar principle as what's going on here.
How do we know when something's being grounded? So you know, like you have like a grounding point, because we assume like the ground is inherently negative, correct? And then
You assume, well, it depends on what you mean by that. You assume that the
one
the ground is at zero potential. Vocabulary for later. All right, ask the question again.
Or we assume that the ground is positive, or like if something is grounded because it's on top of something right now. Maybe it's not neutral,
Oh.
but it's actually. I'm thinking that the straw is actually grounded to something. And
I see what you're saying.
Mhm.
Okay, so let's talk about that. So I have the straw here, and I think what Daniel's speculating is that somehow electrons are getting into it or being taken off of it, whichever way it needs to go, through either from this or through this. Is that?
Yes.
All right. If electrons are doing that, there's a word for it, and I'll just give you a chance to volunteer it. What would this be called if electrons were, say, coming to this from the table?
Conductor?
Oh, that's true. Yeah.
And if it's not possible for that to happen?
Insulator? An insulator?
Yep. So let's bring in those two words. All right, I'm gonna resort to dropping. Conductor and insulator. An ideal insulator the electrons cannot flow through it. That's the word through and flow. Conductor, the electrons do flow easily, and again, using big terms here, easily. It is not saying that for the conductors that we're dealing with, we're not saying that it won't feel any resistance whatsoever. It's just that if I had a conducting material here and another conducting material here, and this one was charged, if I touched them for, a second, enough charge would flow over until it reached electrostatic equilibrium. So generally the rate at which charges would transfer, think on the order of microseconds. So 10 to the negative 6 seconds. That's sort of the order of magnitude to think about in terms of charge flow for conductors. All right, so typically plastics like this are insulators.
Oh, they're insulation, okay.
So now, I don't know if there's something special about this. You've got some materials in there which perhaps need a specialized plastic, but I'm going to play odds that this is an insulator.
Copy that.
So, what would cause it to repel or attract?
Does it have something to do with the magnetic field that's surrounding the object that has a charge, and like the field is what's moving, like applying the force on the straw?
All right,
and
there are a
not
couple
the charge?
things in that. Sorry, I know I stopped you before you finished. You said magnetic field which has a charge. I guess you're thinking of a magnetic charge.
Maybe. I just mean as opposed to like the charge that's on the object causing, like interacting with the straw directly, that there's some kind of field around it.
All
I
right.
don't know enough about it to have the right language.
So as we'll get to in chapter 22, somewhere around there, the magnetism is caused by moving charges. And so in this particular case, I'm assuming the charges aren't moving significantly to cause any special magnetic field. There might be a magnetic field associated with that. I suspect if I put a compass next to it, that needle's not going to care. So I don't think magnetism really has a place here.
So we were still assuming that that still has a negative charge for whatever reason. Where did it come from? Not sure.
All right, so let me do one other thing here. See, is it still repelling? The really nice thing about doing this in January is that works. I've done this in the summertime and it hates it. I bring it near and the charge bleeds off into the air so quickly that it's very difficult to do experiments. So let's neutralize this again. I haven't, that still is whatever charge it was before.
Right.
So it doesn't seem to have an effect on it now. So what I'm heading towards is that it seems like the straw is
Neutral.
neutral. Or if it's charged, it's a weak charge. What happens if I tried glass instead of plastic? Preferred side, I can't remember.
Isn't glass an insulator?
It is an insulator. If this were a metal rod, or if this were a metal rod, what would have happened as I charged it?
It probably would have gotten a stronger charge as opposed to the PVC pipe.
It would have gotten a stronger charge?
Oh, no, because it's a conductor, so it's like easier for the charge to like dissipate, I guess.
Well, it has to go somewhere. Where would it go?
I'm not sure.
If this were a metal rod or that were a metal rod, where would the if it picked up excess charge, where would that charge go? Immediately, eventually it goes into the universe, but
Would it like transfer into your hand?
yes,
Okay.
it did to me. Glass does the same thing, and I did bring this one. All right. There we go. I was hoping one of them would attract. But we still have this neutral object here. And the ability to move it even though that's neutral. Well, we'll leave that as a mystery for right now. Where are we on? All right. I will eventually get used to the new room. But until then, it's going to be awkward. Some logistics, the class footage tends to get posted online sometime in the next couple days. It is usually raw and unedited. I occasionally do go in and edit it, especially if somehow it decided to record everything sideways, or if something was said in class that didn't necessarily went out on the internet, which probably should be a warning to me that there's some things I probably shouldn't say, but it happens. I think on that note, please make sure you've printed out the lab before Wednesday. If you have printer issues, please let me know. And have a wonderful day. Be safe. And let's see, I wanted to talk to Anna briefly. Casey, good to see you again. And Matthew, right?
Matthew's my last name, yes, sir.
Oh, sorry. Wesley?
Yes,
Okay. At this point, hopefully it's not ingrained.
No, you're fine. I've been called Matt. I'm gonna be in Tom, so.
Our course entry assignment, is it on your Blackboard page?
Yes, if you go to